Hello everyone. In this video, we'll understand the various types of operators in Python programming. Without any further ado, let's get started. First, we are going to list down the topics discussed in this video. The first topic of discussion would be types of operators. We'll also understand how operators play a crucial role in making our code work seamlessly. Each of the operators discussed in this video serves a specific purpose, helping us perform different operations in our code. To make things clearer, we'll walk through practical examples for each type of operator, from basic arithmetic calculations to complex logical operations. We have got it all covered in this video. But that's not all. We'll also discuss the concept of operator precedence. Understanding the order in which operators are evaluated is one of the most important aspects for writing efficient and error free code. First, we are going to start with introduction to operators. In this slide, we are going to start this video with a basic introduction to what operators are. Operators are symbols or keywords that we use to perform operations on operands. Think of them as tools that help us manipulate values, make comparisons, and control the flow of our code. So, you might also think, what is the role of operators in programming? Actually, they empower. Operators are very important because they empower us to shape our code, making it dynamic, efficient, and responsive to different scenarios. For example, with operators, we can perform basic arithmetic calculations, compare values to make decisions, and even control the flow of our program through logical operations. So, in the exploration of Python operators, you'll gain a solid grasp of how these symbols and keywords enable us to create powerful functional code. So, let's dive into the world of Python operators. This slide shows the 7 different operators which will be discussed in detail in the further slides. We have we have arithmetic, comparison, assignment, logical, bitwise, membership, and identity operators. Now let's explore arithmetic operators in Python. They are the fundamental tools for performing basic mathematical calculations, making our code more dynamic and robust. We'll be working with the following arithmetic operators. They are addition, subtraction, multiplication, division, modulus, floor division, and exponent. Here addition operator is plus symbol, subtraction operator is minus symbol, multiplication operator is star symbol, division operator is denoted by single slash, modulus is denoted by percent symbol, floor division is denoted by double slash, exponent is denoted by 2 asterisks. This slide, we are going to look at some of the practical applications of arithmetic operators using two variables a and b, which are assigned their values 100 and 200 respectively. As you can see, we are printing the result of a plus b, which gives us the value 300 as the output from adding 100 and 200. Next, we are doing subtraction, in which we are subtracting 200 from 100, b from a. So this gives out the value, negative value of minus 100. Next, we are doing multiplication using the star symbol on a and b, which gives us the value of 20,000. Next, we are doing division. In this division, we get a float value as the output, even if the numbers are completely divisible by each other, we get the integer, no, float value as the output. Here a divided by b gives us the value 0.5. Next we have modulus. Modulus is generally used to get the remainder from the division done on these two numbers. So b by a, whatever remainder we get from b by a is displayed on the output side. Next we do a float division to get the quotient. So if 12 is divided by 5, we get the quotient value as 2. So we are getting the output 2, 2 as the output. Next we have exponentiation, which is done using double asterisk symbol, and this gives out the value of 10,000 from uh, doing the exponent on the 100 power 2. Now we are moving our focus to comparison operators. Comparison operators are basically used to compare two different operands, and they return either true or false. These operators also play a crucial role in evaluating conditions, providing a way for your code to make decisions based on comparison between values. Comparison operators are also known as relational operators, and these are some of the comparison operators which we'll be looking in detail in the next slide. And these operators include not equal to, which is denoted by an exclamatory mark, and equal to. So this basically denotes not equal to. If two operands are given, like a is not equal to b, then it returns the value true, since a is obviously not equal to b. The next one would be greater than and less than, greater than or equal to, less than or equal to. This slide we are looking at some of the practical examples of usage of comparison operators. We are using the same variables as before. We are checking whether a is not equal to b, which in turn gives the output true, since 100 is not equal to 200. The next we are checking a is greater than b, which returns the value false, since 100 is not greater than 200. The next we are checking a is less than b, which gives the value true, and we are checking a is greater than or equal to b. If for example, 10 is greater than or equal to b, will give the result true. As well as this one, a is less than or equal to b, since a is obviously less than b, we are getting the value true in this case. We also have a comparison operator of a is equal to b. That is the equity operator, which is not mentioned in this slide, but it is also important. Then that operator is also used to compare two values and check whether they are equal. If they are equal, the uh, the result is true. If they are not equal, the result is false. Now we are moving on to the next set of operators, which are logical operators. Logical operators are basically used to combine conditional statements. These operators enable our code to navigate through complex decision making scenarios. We'll be working with three logical operators, which are logical and, logical or, and logical not, in the next slide. Here we are having true and true. Since both are true, it returns the value true. If one of them are false, one of the conditions specified in the program is false, then this AND operator, even if the other condition is true, they return the value false. And next one is OR. OR is a bit like, if one of the condition is true, we get true, and if both conditions are true, we get true. The only time we get false is when both the conditions are false. And this one, and the next one would be not true. Not true is used to give the alternate, like the opposite of this. Not true gives false here, and not false gives true. Now we are going to discuss assignment operators. Assignment operators are used to assign a value to a variable which is used to manipulate data in a variable. If no value is assigned to a variable, it may give the result as none, or we might get a error because as we don't define a variable, it is always taken, it will not be taken into a consideration. So assignment operators are really important in Python program. These are some of the assignment operators which we will be discussing in the next slide. Here we have assign, equal to sign. One equal to sign is used to give, assign a value to a variable. In the case of if a double equal to, this can be largely confused with the equity operator, but they are not the same at all. This is basically used to assign a value. We are not checking, or we are not that is used for checking if two values are equal. But in max we do the opposite, we don't use double equal to and all. But in the case of Python, we use only single equal to for assignment and double equal to for equity. The next one is add and assign. And the other one, add and assign, basically you gives like if I plus or equal to 1, which means I is equal to, I is assigned the value of I plus 1. If I is given already is assigned the value of 2, then 2 plus 1 gives 3. So the new value assigned to I is 3. Next is subtract and assign, multiply and assign, divide and assign, and modulo and assign. To understand the practical application of assignment operators, we are going to see some of the real time examples using Python. We start with A, assign the value of 100. So first we are adding and assigning the value of 2 with A. So this basically implies A is equal to A plus 2, or we can write this as like this also, A plus equal to 2. And since we are printing A, this result will be displayed as 102 with the updated value. And next we are doing A minus equal to 2, which gives out the value 100. Next we are doing A star equal to 2, which basically implies A is equal to A multiplied by 2. So A is assigned the value of 2 times of A, which is basically 200. The next is A divided or a slash equal to 2, which gives out a float value 100.0. Next is modulo function. We are using modulo of like A is A modulo equal to 10. Since there is no reminder which will be getting from 100 divided by 10, we are assigning the value of A as 0. Next, will be exploring bitwise operators. Bitwise operators are used to perform precise operations on individual bits of binary numbers, offering a powerful method to manipulate data at the binary level. For this, we first need to understand the perception of binary numbers, how we calculate the binary bits of a number. The bitwise operators which will be discussed in the video are bitwise AND, which is denoted by the ampersand symbol, bitwise OR, which is denoted by a straight slash, and bitwise NOT. Then the last one is bitwise XOR. In this slide, we'll be looking at some of the basic operations on numbers using bitwise operators. So first we are assigning two variables a and b with the values 4 and 10 respectively. These values are expressed in bits here as a comment, so people can understand how bits are expressed. Like bits are used basically based on the position. So if it means if this 0 corresponds to 2 power 0. If 2 power 0 term is there, like 1 should be added for all the odd numbers, this will be there. This will be 1. And the next one is 2 power 1. This one is 2 power 2. And this goes on till the last bit, which is 2 power 7. All the numbers can be expressed in terms of bit using the position thing. Like 4, since 4 is there, we have 1 in the place of the third bit. Like 2 power 2 gives out 4, so we have 1 here. And the next one is 10. 10, in this case we have 1 in the place of 2 power 3 and 1 in the place of 2 power 1. So 2 power 3 is basically 8 and 2 power 1 is 2, which in addition gives out 10. Now we'll look at some of the operations using bitwise operators, like AND. Here for example, AND is used. This is bitwise ampersand, bitwise AND A and B. If two conditions like 1 and 1 is given, this will return out as 1. If 0 and 1 is given, it will give return out the value 0. Since no places are identical with 1, we get the value 0 for this. And next we are using bitwise OR, which is denoted by the straight slash symbol. Here we are checking like OR condition is used. This is false, 0 is false and 1 is true. So what true or false gives out true, so 1. And true or false gives out 1 as well. False or true also gives out 1. So the bitwise number which corresponds to this expression is 40. And next one is bitwise XOR. If these two are not equal, we get the value 1, just like AND symbol, but this is used for like 0 not 1, so we are getting 14. And also we will be using AND, sorry, not, bitwise not A. So all the other things will be given as 1 1 1 1 1 0 1 0, sorry 1 1, which will give out the value -5. Next we will be focusing on membership operators, which is the sixth one. Membership operators are basically used to check membership of an element in a sequence. The sequence may be a string or a list or a tuple. These are some of the membership operators. There are basically only two here, unlike others like one in or not in. Here we are going to look at some of the examples of membership operators. We are giving an assigning a string to the variable string str here, and we are printing whether if o is in string, we'll get, since o is already in string, we get a value true. Since e is also in string, but we are doing the not in we are using not in membership operator, so the value will return as false since e is already present in the string. Next let's do it with a list. In this list we have defined three elements: 9, member, it is a string, and this is a tuple. Here 9 is in the list, so it returns the value true. Since 10 is not in the list, we are getting the value true as well, because this is a not in. If the value is not present in the list, it will return the value true. Now, the last type of operators is identity operators. This identity operator is used to compare memory locations of two objects. And the commonly used identity operators are is and is not. In this slide, we'll be looking at some of the examples of identity operators. Here we have a list which is assigned to the variable a, and the same kind of list is like assigned to the value c as well. So variable c as well. But in this case, they are not stored in the same memory location. So a is c will return the value false, and a is not c returns the value true, unlike the membership operators. People might confuse this for that, but identity operators are specifically used to check the memory location, not membership. Next, we have arrived at the final topic which will be discussed in this video, which is operators precedence. Operator precedence is usually given as the order in which operators are evaluated in complex expressions with more than one operators. So if more than one operator is used in an expression, the system will evaluate the answer based on operators precedence. This is abbreviated form of the operators precedence, which will be easy to remember. Here the P stands for parenthesis, E for exponentiation, M and D for multiplication and division, A and S denotes addition and subtraction. Here, since multiplication and division and addition and subtraction have the same level of precedence, we'll be using one more rule called associativity rule, which states that the operators should be evaluated from left to right. If addition is present initially, addition will be done first and then subtraction. Now we are going to look at some of the examples of for getting some clarity on operator precedence. Here we have some, like, since we have parenthesis first, we'll be evaluating these two expression first, which is 5 plus 3 is 8, and 3 exponent 2 is 9. The result is 9. So 8 into 9, since this multiplication and division has the same precedence, we'll be multiplying these two first. 8 into 9, which gives 72, and this is divided by 4, and the final result is 80. The next example also tells us about operators, gives us some clear idea about operators precedence. Here we have 2 plus 5. The first thing we need to do is eliminate all the terms inside the parenthesis first. Like 2 plus 5 gives out 7, 1 plus 2 gives out 3, and the next one would be exponentiation. Since exponentiation has more greater precedence than multiplication, division and subtraction, we'll do the exponentiation before all these operations, and 3 power 2 gives out 9. Here we have the same kind of rule, multiplication and division. So from left to right this is operated. So 9 into 7 is 63, and 63 divided by 9 is 7 minus 4, which gives out the final result as 3. So that's all for this video. As we conclude our exploration of Python operators. I hope you gained a greater understanding of how operators work and also some of the basic operator precedence rules. Do execute some of the programs using these operators in Python yourself to gain much more practical sense of how these operators work. And finally, thank you for watching.